So here's video solutions to the practice test unit for scientific notation. The U.S. produces 4.34 times 10 to the fifth metric tons of wheat each year. Express that number in standard form. So we know that we simply take the 4.34 times 10 to the fifth. We're going to move that over 5 places. So 1, 2, and then it goes over 3 more. So we have 3 zeros. We've done this a lot, so this should be fairly easy. And then we're going to rewrite it. So 434,000 tons of wheat each year. The number 6.9 times 10 to the 6 written in standard notation is, so again, same type of problem. So I have 6.9. I'm going to move it over once, and then I'm going to move it over 5 times, which makes our 6. Then I'm going to rewrite it. So that's going to be 6,900,000. So don't try to do this in head. Show the work, and you'll get these right. Number 3, a certain bacterium has a radius of 2.5 times 10 to the negative 7th meters. What is another way to express this number? So this is very small. So I have 2.5. We know negative means I'm going to go in the opposite direction. So it's a decimal. So I'll go over once. So I need to go over 6 more. 3, 4, 5, 6. Then my 0 point. So that is 1, 2, 3, 4, 5, 6, 2, 5. Use scientific notation to simplify expression. When we multiply or divide numbers in scientific notation form, we do the numbers with the numbers. So it's going to be 5.6 divided by 4.0, and then the 10 to the 7th divided by 10 squared. So 5.6 divided by 4.0. We don't need the 0.0, so I'm going to bring this decimal up. 4 goes into there once. That's 4. Bring down the 6. 4 goes into 16 4 times evenly. So 1.4. Is that 1.4 ready for scientific notation? Yes, it is. Then when we do division of powers, we subtract the exponents, top minus bottom. So that's going to be 10 to the fifth. So our new answer is 1.4 times 10 to the fifth. And double check that that's in scientific notation, which it is. What is the value of the number that is 10 times as large as 3.4 times 10 to the 6? Write your answer in scientific notation. Well, we know that if I were to take 10 times as much on this 3.4 times 10, okay, would be a 0, go over 0. So I got 4, 3, there's 1 decimal place. So that would be 34. That's like moving the decimal over 1 place. We've learned in this unit that every time we multiply or divide by a power of 10, we move the decimal over 1 place. So if I multiply by 2 powers of 10, I'd move it over 2 places. If I divided by 2 powers of 10, I'd move it to the left 2 places. So basically what I'm doing here is I'm saying instead of 10 to the 6th and moving the decimal over 6 places, I'm actually now going to move it over 7 places. It's no different than saying if I had if I have a dollar bill and now I have 10 dollar bills, okay, then that's a $1 $10 bill. So I'd move the decimal. If I had 10 tens or 100, that's the same as one $100 bill. So every time I have 10 more of something, which is 10 times as big, I move the decimal over a place. So in this case, it would be 3.4 times 10 to the 7th. Okay? And we would have gotten that here too because I had to write my answer in scientific notation. So 3.4, if I moved it over and my new number was 34 times 10 to the 6th, we know that that decimal would have to move back a place. And when it moves back a place, okay, then I'm going farther away, and that would have changed it to 3.4 times 10 to the 7th. What is the largest number? Well, we know that we compare the place value if they're all in scientific notation, which they are. So in this one, that's negative, so we know that's not largest. Okay, we have 10 to the 5th, 10 to the 5th, and 10 to the 6th, so these aren't. So I'm left with 3.08 times 10 to the 6th. That's the largest number. Just make sure they're in scientific notation. Okay, Mrs. Furtado is an astronaut and she thinks of everything in terms of scientific notation. She would tell you, for example, she has flown 1.6 times 10 to the 5th miles on her favorite airline, and that is exactly enough frequent flyer miles for 4 free tickets. In scientific notation, how many miles are needed for each ticket? As soon as we hear that how many for each, we know it's a division problem. So I have 1.6 times 10 to the 5th, and I'm going to divide that by 4. So in this case, numbers with numbers, powers with powers. So I take my 1.6 and we're going to divide by 4. All right, so I'm going to bring the decimal up. And 4 goes into 16 4 times. That's exactly 16. So I have 0.4 or 0.4 times 10 to the 5th. My computer's running a little slow here. Okay, so now we need to put it in scientific notation. So that means I have to move the decimal over one place. So if I move it over here, that means I'm getting closer to 10 to the 5th. So that's going to be 4.0 times 10 to the, and getting closer, going in the same direction as this 10 to the 5th, means that I subtract 1 from that. So 4.0 times 10 to the 4th, or approximately 40,000 miles. Computer's running really slow. Which of the following is not true? Well, I'm just going to change these all into standard form. So that's go over one place. So that's a 5 and a 3 with 2 zeros. Go over 5 places. So that's 1, 2, 3. So I'd go over 2 more places. So that's 5,300. So that's the same. Okay, go over 2 places here. 1, 2. That's going to be 140. And over here I'm dividing. So I go back 2 places. 1, 2. So that's 14. Well, there you go. 140 is not equal to 14. So that's your answer on that one. Okay, if all the planets' masses were expressed using scientific notation, which planet list would have the highest power? Well, first of all, I'm going to use some of my science knowledge. I know that it has to be a bigger planet, so like Jupiter, Neptune. So let's go to Jupiter. Well, I need to put in scientific notation, so that means that right here would have to go back 2 places. If it goes back 2 places, that means I'm farther away from this 21. So that means that new exponent's going to be a 23. So it's going to be 2.09 times 23rd. So let's do Uranus. If I go back 1 place here, that means I'm going to have 9.57. And again, I'm going farther away, so that's going to turn to a 22. So that's still smaller. Well, right here, Neptune, there's my decimal. I have to go back 2 places. So that's 1.13. If I go farther away from the 20, that's a 23rd. So that's the same as Jupiter. But Jupiter is 2.093. Neptune is 1.13. So Jupiter is the largest. The product of 800 and 300 expressed in scientific notation. Well, I know that the 8 times the 3 is 24. So remember how to do this from Unit 2 where we multiply the number parts and then just add the zeros. Then I have 4 zeros. 2, 3, 4. So that's 240,000. If I put that in scientific notation, my decimal goes right there. So it's going to be 2.4. And here's where my decimal was. So that's 1, 2, 3, 4, 5 places. So that's going to be 10 to the 5th. So some of these are fairly easy problems. What would the multiplication of 4,600,000 and 230,000 look like written in scientific notation? Again, I just multiply the numbers together and add the zeros. So I have the 46 and the 23. So I'm going to multiply those. And I'm going to get, you see that's an 18. So 12, 13, go over a place. So that's 12. So that's 8, 9. Add those up. So I get 8, 5, 10. Okay, that's not ready for scientific notation. So I have my zero. So I have 1, 2, 3, 4, 5 zeros there. 1, 2, 3, 4, 5. And then I have 1, 2, 3, 4, 5, 6, 7 there. So I have to add 7 more. So 1, 2, 3, 4, 5, 6, 7. And now put it into scientific notation. So this is where I put my decimal right there. So it's going to be 1.058. This is where my decimal was, way over here. So how many places is that? Well, let's just cross them off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, last count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that would be 10 to the 15th. Okay, one more and then I'm going to do a new video because it's just taking too long. The computer's just not running very quickly. The number 0.00069 is written in the form 6.9 times 10 to the n. What is the value? Well, we just want to know the exponent, so just put this number into scientific notation. So here's where I would put the decimal. Here's where it was. So that means I'm going to go 1, 2, 3, 4 places to the left, so that n would have had to have been a negative 4. Okay, so let's take this as just half of it, and then so number 13, if the number 7.23 times 10 to the 5th is multiplied by 10, the product expressed in scientific notation would be, well, this is like that other problem where we said if it was 10 times greater. So we know if it's multiplied by 10 that I either move this decimal over one place, which in turn makes me have to change this, or if I multiply by another 10, instead of 5 tens being multiplied, there would be 6 tens. So this would be 7.23 times 10 to the 6th. So every time we multiply by a 10 or divide by 10, we either add or subtract from the exponent. In the expression 86,000 equals 8.6 times n, what power of 10 should replace n to make the statement true? So we need 10 to something. Well, they're just asking you to show what it looks like in scientific notation. So if this is where my decimal is, and that's where it was, that's 1, 2, 3, 4 places, so that would have to be 10 to the 4th. 4 times 3, or 4 to the 3rd power times 4 to the 5th power expressed as a power. Well, we know that when multiplying powers at the same base, we simply add the exponents. That's 4 to the 8th. The number of visitors to the Canadian National Exhibition in 1998 was 2.04 times 10 to the 6th. The number of visitors to the Pacific National Exhibition was 1,558,231. Which exhibition had more visitors? So that means we have a subtraction problem. So I'm simply going to change this number right here into scientific notation. We know from class that when we have the powers being exactly the same, that we just add or subtract the number part. So this should be, that'd be 1.558231, and then that would be, that's over 6 places. So I know I'm going to have a 2.04 times 10 to the 6th. Okay, so that's going to be minus that 1.558, etc., times 10 to the 6th. So I'm just showing you that what that would kind of look like. So now we subtract the 2.04 minus that 1.55, and unfortunately we have to line everything up. 8, 2, 3, 1. So these would all be zeros. Okay. So I'm going to do lots of borrowing here. So you just take your time and make sure you don't make mistakes on this part of the math. So that's going to be a 9, 6, 7, 1. Okay, I have to borrow again. So that's 11. So that's 13. 13 minus 5 is 8. 9 minus 5 is 4. And I don't have any decimals. And we know that both of these were 10 to the 6th. Now, is this number in scientific notation? No. So I have to move this decimal over. Well, it's actually going in the same direction as 10 to the 6th. So that means it's going to be less. So I'm going to have 4.81769. And now that's going to be 10 to the 5th would be the correct way to write it in scientific notation. So which exhibition had more visitors? Obviously the Canadian one did. And then how many more? Would be that many. And it didn't say to write in scientific notation. So we could go this way too. So 1, 2, 3, 4, 5. So that would actually be 481,769. Okay, the Diplodocus dinosaur is believed to have been extinct approximately 1.38 times 10 to the 8 years ago. The Oviraptor is believed to have become extinct probably 7 times 10 to the 7th years ago. How many years were there between the extinction of these two dinosaur types? So again, that's subtraction. How many years between? So I need to take, I'm going to take my 1.38 times 10 to the 8th. We know that's bigger because that has a bigger power. And I'm going to subtract this one, but this one is not in scientific notation. I mean, it doesn't have the same power. So we need to make that an 8. Remember, we're always going to make the small one a larger one. So if I have 7 times 10 to the 7th, I need to go farther away. So if here's my decimal, I have to move this decimal farther away. When I move it farther away, this 10 to the 7th becomes 10 to the 8th. So my new number would be 0.7 times 10 to the 8th power. Now I can go ahead and subtract numbers minus numbers, powers minus powers. So that would be the Diplodocus minus, and then this one right here, 0.7 times 10 to the 8th. So let's take our 1.38 and we're going to subtract our 0.7. So it looks like we're going to have to fill in that space right there. And then when we subtract, we get 8. We need to borrow. 13 minus 7 is 6. So I have 0.68, and then we know we keep the power the same times 10 to the 8th. So we need to put that in scientific notation. So this decimal has to move from here, has to move over to here. And that's getting closer to the 8 because this is a positive. So when it gets closer, I take away from the power. So that's 6.8 times 10 to the 9th. All right, so that's how many years between them. Better double check that though. Why would it? So that's adding another 0. Oh, I know. See, that didn't make sense. I was adding more time instead of subtracting it. When I go to the right, which is the same thing as I'm doing with a positive exponent, that means I'm subtracting 1. So that would be 10 to the 7th. There we go. So that makes more sense. All right. Find the value of n for the following. Well, we know that I'm going to take 3 to the 12th plus the n. That's what that means when I multiply powers with the same base. I add the exponents. So basically I have a simple algebra problem. I have 12 plus n and that has to equal negative 15. So now this is like solving an equation from 7th grade. So to get the n by itself, I have to get rid of the 12. It's a positive 12, so I'm going to do a negative 12 on both sides. So negative 12 and negative 12. So the 12 and the negative 12 cancel. And I'm going to be left with n equals, this is not subtraction, we have a negative 15 and a negative 12. So it's actually an addition problem. So that equals negative 27. So you have to know your integer operations. Which of the following expressions is not equal to 1? We know anything to the 0 power is 1. We know 1 to the 5th means I'm using the 1 5 times and multiplying, so that's 1 times 1 times 1 times 1 times 1, which would be 1. We know the square root of 1 is 1. We know that this negative, having this odd integer, that would be a negative 1 times 1 times 1, because there's no parentheses here. So in the end, that's going to be a negative 1, which of course is not equal to a positive 1 like they wanted. Okay, number 20. Okay, when we have a power to a power, what we do there is we multiply the powers. So you take that 6 and you multiply it times the 3. So that's just a simple rule, very easy. So I have 2 to the 18th power. So a power to a power just means you multiply them. Rewrite 3 to the negative 2 power using a positive exponent and evaluate the results. So we did this back in Unit 2 on roots and radicals. We don't want a negative power in this situation. So we're going to make the whole thing a fraction. And then what we said back then is we're going to take a highlighter and we're going to highlight the powers that have a negative exponent because we know we're going to move those. Okay? Those are going to be moved in the fraction. So in this case, I have my fraction. This power is going to move from the top to the bottom. That's why I highlighted it. And when it does that, that negative 2 becomes a positive 2. Everything else stays the same. In this case, there wasn't anything else, so I have to put a 1 on top. Now, evaluate simply means I do any more math I can. Well, 3 squared I know is 3 times 3, so that's going to end up being 9. So our answer is 1/9. Write the expression 10 to the negative 4th in standard form. So we don't want this as a fraction. We know this is a power of 10, so it's going to be a decimal. So that means that I have 0. 10 to the negative 4th means I'm going to move it 4 places to the left, okay? So if I have 4 places to the left to make it standard form, I have to have 4 places in my number to do that. So again, 10 to the negative 4th, so we'd have a 1, and then 4 places to the left. 1, 2, 3, 4, and of course there would be our 3 zeros there. If this were a positive 4, we know that we just add zeros to our number. That would be a 1 with 4 zeros. But in decimals, we don't have a ones place. So 10 to the negative 4th means I just have 4 places. 10 to the negative 5th would be 5 places. 10 to the negative 6 would be 6 places. And 23. The distance of the Earth from the Sun expressed in scientific notation. Well, right here, Earth to the Sun, so that's our 93 million. So if I put my decimal right here, okay, I know that it was here, so that's going to be 9.3, And that's 1, 2, 3, 4, 5, 6, 7 places. So 9.3 times 10 to the 7th. All right, number 24. If 9 times 10 to the 8 is multiplied by 2 times 10 to the squared, the result expressed in scientific notation. So we know that we multiply numbers times numbers, powers times powers. So we're going to take the 9 and we're going to multiply by the 2. And in that case, we're going to get 18. And then we're going to do the power. So that's 10 to the 8th times 10 squared. So we know that's 10 to the 8th plus 2. So we add the exponents. So 8 plus 2 is 10. So that's going to be 10 to the 10th power. Got to remember those rules. That's why those notes are so important, those foldables. Whoops. Okay, so that's 10 to the 10th. All right, this number is not in scientific notation. Here's where the decimal is. I have to move it back. If I move it back, I'm getting it farther away from 10 to the 10th. So that means I have to add to that. So that's going to be 1.8 times then 10 to the 11th. And I think that's it.